All right, so today we're going to take a look at a different kind of proof called coordinate geometry proofs. And so a lot of the things that we've proved so far can be proved just as easily or sometimes easier using imagining our figure on a coordinate plane. And so we're going to use this as a first example. We're trying to prove that if it's given that B is a right angle in triangle ABC and D is a midpoint, then we're going to prove that the area of triangle ADB is half the area of triangle ABC. Okay, and so when we do coordinate geometry proofs, we can set up our figure wherever we want on a coordinate system, and so I'm going to put the triangle, since it has a right angle, it would be natural to put it right here like this. So this is point C, this is point B, this is point A. Okay, and so we just need to give coordinates for those points. So when I put a coordinate on the x-axis, which coordinate do we know for sure? Any point that's on an x-axis. What is B? Yeah, so we do know the coordinates for point B are 0, 0. But what about any other point? So you're correct on that. But what about any other point that's on the x-axis? Do we know either the x or the y coordinate? That's right. The y coordinate would have to be 0. And so we know for sure this is 0. And then similarly on the y-axis, we know that the x coordinate has to be 0. Every single point on the x-axis has an x, or sorry, on the y-axis has an x coordinate of 0. Okay? Now we can name we want this triangle to represent any possible right triangle that we can make. So these x coordinates can be anything. Hopefully you're all writing in pencil because I'm going to have you erase in just a couple minutes, but I'm just going to go through this process so you understand it. We can put any variable we want here and any variable we want here. Okay, so I'm going to call this lowercase a and lowercase b to start with. Okay, now that's where you're going to end up erasing that in just a few minutes, but I'm just going to start with that. So we can name those anything we want. So a and b could represent any constants. And the reason why we are doing that is because now for point D, we said point D is a midpoint. So we know how to find the midpoint using coordinates. Who remembers how to find the midpoint when we know coordinates? Okay, Adeline? Okay, so we find the average of the x's, so x1 plus x2 divided by 2, and the average of the y's. And so in this case, it would be 0 plus a divided by 2. That's the average of this x coordinate and this x coordinate. Okay, and then the average of the y coordinates would be b plus 0 divided by 2. Okay, so we end up, if we simplify that, we end up with a over 2, b over 2. Okay, now most people don't like to work with fractions. So I'm going to show you a little trick that we can use in the future that will help prevent fractions. So remember when we named these coordinates, the a and the b, we said they could be anything, they could represent any constants. Well, if I make those even multiples of a and b, then we won't have any fractions. What I mean by that is, so here's where we're going to erase. So let's erase what we did so far. We'll erase that. And then instead of calling this point A, if I call it 2A, and I call this y coordinate 2B, now I'm going to prevent fractions, because look at what happens now. When I find the midpoint, this is going to be 0 plus 2a divided by 2, and 2b plus 0 divided by 2 when I do the average of the x's and the average of the y's. And now I get just simply 2a over 2 is a and b. So that's a much simpler expression to work with. as opposed to what we got originally. Remember, we had the fraction a over 2 and b over 2. Well, now we have avoided the fractions. Now, it wouldn't be the end of the world if we had to work with fractions. Sometimes it's unavoidable. But when we can avoid fractions, it makes everything a lot easier by whenever we're giving generic coordinates like a and b, why not call it 2a and 2b? Because then whenever we find midpoints, then we know that we're going to have even numbers, and that'll be divisible by 2. Okay, so it's not required, but it's just a little trick that you can do to make the calculations easier. Okay, now we're trying to find the area of triangle ADB. So triangle ADB would be the area of this triangle. Okay, so let's see if we can do that using our coordinates. Area of triangle ADB is equal to area of a triangle, remember, is 1/2 base times height. Now, looking at our coordinate drawing, what is the base of triangle ADB? How long is this? That's our base. Can you look at the coordinates and tell me how long that is? What should we be looking at, the x's or the y's, to get a horizontal distance? Okay, Caitlin? The x's. So if we go from 0 to 2a, how far have we gone? 2a. So our base is 2a. And our height, this one's a little bit harder. Can anyone tell where we should be looking to get the height of that green triangle? Think of coordinates. If we're trying to find this length, that's our height. That's an altitude. Remember how to find altitudes perpendicular to the opposite side. So that's the height of that triangle. To find the length of that dark blue segment that I just drew, we should be looking at an x or a y coordinate.
Y.
The y coordinate of what? Of which point? Isn't this point D? And D has the coordinates we said A, B. So that means the height, the y coordinate always gives you the height. So that height is B. So now we have area equals 1/2 of 2a times b. And again, we see how the having the 2a in there helps us avoid the fractions. 1/2 of 2a is a, so we just simply get AB. So the area of triangle ADB is equal to just simply AB. Okay, now use coordinates. You're going to do this in your groups. So now use coordinates to find the area of triangle, the big triangle ABC. Area of triangle ABC. Go ahead and discuss that in your groups, and I'll call on one of your groups in just a moment. Okay, so again, we're saying that the area of any triangle is 1/2 base times height. And the base, so this time we're looking at a different triangle. So I'm going to highlight the triangle that we're looking at. We're looking at this whole yellow triangle. Okay, and Elsa, can your group tell me what the base of the yellow triangle is? Okay, Spencer? 2a is correct. Okay, the base of the yellow triangle is this, and we already have it labeled as 2a. Okay, And then, Kartik, how about the height of that triangle? Good. So this height is 2b, and so our height is 2b. And so now when you multiply those, we get 1/2 of 4ab, which is 2ab. And so compare these. We've now proven that the area of triangle ADB is half of triangle ABC. So let's write that. So we can just say, therefore, the area of triangle ADB is half the area of triangle ABC. And that's what we were trying to prove. Any questions on that? So that's an example of a coordinate geometry proof where we use generic lengths like A and B, or a 2A and 2B, to make sure that this figure represents any possible right triangle. And so we've basically proven that if you find the midpoint of the hypotenuse, you get a triangle that is half the area of the right triangle.